Hey everyone, Dr. Jenkins here. This lab video is going to be about the Digestive Physiology lab. So you'll see in your lab packet there's one called Digestive Physiology. Just going to review some basic terms. Then we're going to talk about what happens in the lab. And then one more thing to talk about, which I'll move the screen for digestion and surface area. So let's just start with some basic terms. Make sure for this laboratory that you can define digestion. We know that digestion means to break down. We bring in a big nutrient and then we digest it, break it down into smaller pieces. We can do digestion or breaking down through mechanical means or chemical means. Mechanical means that we break up food using mechanical means, physical means, like chewing, or like when the stomach churns, that's mechanical digestion. But we can also do chemical digestion. And that is breaking down food through chemical means, through the use of, you guessed it, enzymes. So this laboratory is all about enzymes, which do chemical digestion. Let's talk about enzymes. What do enzymes do? Enzymes are small proteins, and what they function to do is speed up or catalyze chemical reactions. Excuse me. A chemical reaction, dropping all sorts of stuff. Chemical reactions would happen pretty much regardless, but they'd happen so slowly without the enzymes. So we absolutely need enzymes to speed up chemical reactions to have any chance at getting our chemical reactions done quickly enough. So enzymes speed up chemical reactions. They are reusable. That's a good thing. So we can use an enzyme, speed up a chemical reaction, and the enzyme will leave unchanged and it can be reused again. Enzymes are specific to a substrate, so that means that amylase as an enzyme can only work on starch. Lipase can only work on fat. Protease can only work on protein. So each individual enzyme, it's like a lock and a key or a puzzle piece. Each individual enzyme only fits into a specific substrate, or in this case, nutrient, macronutrient. Typically, enzymes add in the suffix ase. You've heard me say it already, amylase, protease, lipase. Dead giveaway, that is an enzyme. We have others across our body, acetylcholinesterase, pyruvate kinase, and so forth. Last thing I want to point out is that enzymes work faster at a slightly higher temperature. This is one benefit of why it's beneficial that our core temperature is slightly warmer, about 38 degrees Celsius or 98.5 degrees Fahrenheit. At a slightly warmer temperature, enzymes work faster. At too high of a temperature, the enzymes will begin to denature or unravel, and that's bad. But a slightly higher temperature is good. All right, I'm going to switch this around. Don't mind me. Let's talk about the lab procedure. Hello. In today's lab, what you would have done is you would have started with 3 macronutrients. We start with starch. We start with a triglyceride, which is a lipid. And then we start with protein. To each of these nutrients, we're going to add an enzyme. I'll use blue. So you can see here enzyme used. You should know these enzymes. To starch, we added the enzyme amylase. To triglycerides, we add an enzyme called lipase. To the protein, we add an enzyme called protease. In some of the lab instructions, it'll say using an enzyme solution called pancreatin. Pancreatin contains lipase and protease. It's a specific enzyme for each. The specific enzyme for a triglyceride is lipase. The specific enzyme for a protein is protease. So what's going to happen? If we start with a macronutrient, we add to it the amylase. Won't the amylase help to chemically digest the starch? Well, yes, it will. It'll speed up the chemical digestion of starch. So what we do is we start with starch, we add amylase, and what is that going to yield? It's going to yield, we start with starch, we break down into the smallest structural component. Starch, you may recall from A&P1, starch is a big complex carb. So we start with a complex carbohydrate, chemically break it down into a simple sugar called glucose. So it's just kind of simple if we break it down. We start with a big molecule, we add the enzyme to help chemically break it down, and once this is chemically broken down, a big complex carb gets broken down into a simple sugar called glucose. Make sure you know, boom, boom, boom. Well, what about triglyceride? Triglycerides, we add lipase, which is going to speed up its chemical digestion. And of course, the end products of triglycerides that we remember from AEP 1, Chapter 2, would be fatty acids and glycerol. Start with the big thing, add the enzyme, which helps break it down into its smallest structural components. Know those three. What about protein? We start with protein. We add the enzyme to speed up its chemical reaction. Everyone should know this one. What do we break down our big proteins into? Of course, it's amino acids. This is a simplistic lab, or a simplistic idea, but it's so central to everything that happens, right? Almost every chemical reaction has enzymes. And this is an example, chemical digestion. We would not be able to chemically break down these nutrients without these enzymes. So you should know what we started with, what enzyme we used, and what it got broken down into. On the far to my left, your right, is the indicator solution. You do not have to know these specifically, but I want to remind you of what an indicator solution does. An indicator solution changes color to tell us whether or not something is present. So if we look at glucose and starch, the two indicators that we used, come on in, just prepping a video for my online students.
Oh, sorry.
Is that okay right now?
Oh, yeah, just...
Sure, go for it. All right, so the indicators that we used were, we used iodine, because iodine, if a substance is positive for iodine, the color will turn dark blue or black. So we know something is positive for iodine if it turns dark blue or black. We also use an indicator called Benedict's for glucose. I know that you've used this reagent or this indicator somewhere in your career here in a lab or maybe another lab. Benedict's makes the color of a solution turn red, green, or orange if it's positive for glucose. So positive for glucose if it's red, green, or orange. Again, you don't have to know the specific indicators, but you should know what an indicator is. It's something that changes color to tell us whether or not something is present. I'm going to fill these out just so we can say we completed these parts of the table, but you do not have to know them. The indicator that we used for the triglycerides was basically an acid-base indicator. Because we're breaking down the triglycerides into fatty acids, we know that the triglyceride has been effectively broken down when it turns acidic. And in the lab that this lab manual goes through, if the solution turns pink, it's acidic. So we knew digestion happened when the solution turned pink. And if it was blue, we knew that it was alkaline or basic. And lastly, the indicator that we used for protein was something called VAPNA. Even I don't know what that stands for, some crazy chemical name. But this, when it turned yellow, it was positive for amino acids. So it's positive for amino acids when it turned yellow. Again, you don't have to know those indicators specifically, but as I said 2 times already for a 3rd time now, just know what an indicator is. It changes the color of the solution to let us know whether or not something is present. Okay, last part of the lab. Here we go. Let's switch it over this way. Move it over this way. Oh yeah, the fun continues. Saw my pin, right? I love physiology. It's true, it's true. Okay, so the last thing we looked at in this lab is how digestion is influenced by surface area. This is kind of hard to see. Let me move this over. We're just going to make it work. The benefit is if you were asleep during this video, now you're awake. Okay, so in this lab, what we had you do is we took a whole piece of potato, we took a mashed piece of potato, and potato flakes. And we added amylase, because potato contains starch, and we let the amylase help to chemically break these down. The question is, which one digested the quickest? The one with the highest surface area, or the one with the lowest surface area? And as you might not be surprised to learn, get this off, a greater surface area means we can do more digestion. Really important point. A greater surface area means that we can do more digestion. And this is a tenet that we utilize all throughout our body. Think about the small intestine, 19 feet long. The idea of having 19 feet worth of intestine is you have 19 feet worth of cilia and microvilli with which to do chemical digestion and absorption. The more surface area, the more digestion. But why? The reason is it has to do with the enzymes. So let's take our whole potato, and I have a really rudimentary drawing. If I just have a whole potato, maybe I can only fit 1, 2, 3, 4, 5 enzymes on it. So a whole potato piece maybe only has space for 5 enzymes to fit. So smallest surface area, least amount of digestion, because there's the least amount of space for enzymes to bind to the substrate. The mashed potato, maybe instead of just 5 enzymes, now I can bind enzymes to both sides. Because I've mashed the potato, I've got more surface area. So instead of 5 enzymes I could fit for the whole potato, now I can fit 2, 4, 6, 8, 10 enzymes. More surface area, more enzymes can bind, more quickly we can do chemical digestion. The flakes digested the most because they have the greatest surface area. So I could bind enzymes around each individual flake. If I can bind 3 enzymes around each individual flake, and there's 20 flakes, that's 60 enzymes. So the takeaway point is, the greater the surface area, the more the more chemical digestion I can do. Why? Because I can fit more enzymes. The greater the surface area, we can bind more enzymes. That's it for this lab. See you next time.